something I forget to do often. And you can choose any way, but this is what we're going to choose for today because it's simpler. Alright, it's more of a simple problem. So, sum of the forces in the y, they're going to be equal to 0. And it's going to be Fya plus Fyb minus 1200 newtons minus 900 newtons. Okay, so we have two unknowns and one equation for the moment, but we're going to expand that equation, and let's take the sum of the moments around point A. So we're going to have, remember, a moment is a force times the distance equals moment. Okay, so we'll say that our force is going to be 1200 newtons times 2 meters, and that's going to be negative, okay, plus 1, 2, 3, 4.5, 5 meters times Fyb, and that's positive because it is acting in the direction that we declared positive, and minus, let's see here, 1, 2, 3, 6 meters times 900 newtons. Okay, and this is going to be equal to 0. Forgot to put that there, but let's keep going here. So that's going to be minus 2400 Newton meters plus 4.5 Fyb minus, shouldn't need a calculator for that, but I'm going to use it anyways. Yep, 5400 Newton meters. Okay, and this is equal to 0. So, let's solve for Fyb. Let's say, here, I'm going to use my calculator. Put that there so you can see it. Alright. Let me make some adjustments here. I'm trying out this new camera setup. Alright, so 5400 plus 2400, it's going to be negative 780 minus 780 Newton meters, 4.5 Fyb. Okay, so let's bring this over here, so 780 there. Okay, and this is just the algebra, which is usually the place where I make my mistakes. Okay, so we know our Fyb is 1733.33 newtons. Okay. The reason it's newtons, obviously, is I didn't write it here. But this is meters. Alright? 4.5 is the distance. So we know now Fyb. Let's bring that back up here and put it in to our first equation. We'll call this 1, and we'll call this 2. Okay? So put Fyb into equation number 1. Alright, and solve. So, let's see here. Okay, and we can solve for Fya, which is going to be equal to, what's this? It's going to be here 2100. So I'm just subtracting here, I'll show you. So 2100, this is negative, but when we move it over here, it'll be positive, so we'll do 2100 minus 1733. It's going to be 366.67. Okay. So that is our force in the y direction at point A. It's telling us to find the internal loading acting at the cross-section C. So this is our first step in doing the problem. The second step is going to be to draw another free body diagram at point C. So let's go ahead and do that. Get my straight edge again. Okay. Just make sure you guys can see me. Yep. Alright, we're good. So point C is, we'll extend it out to here, just for sake of visualization. Okay, and so this is member AC. Okay, and just imagine that we take a knife and slice the rod at point C. What's happening here is we're going to split it into two different rods now. It's going to change our distributed load on the new free body diagram. And draw it like that. This is really just a cross section right here. Call that C, little c, little c. Okay. Call this X, and this will be our Y. Okay. So we know the force is acting on the member Fya equals 366.67 newtons. Okay. We also know that this member has a distributed load acting like this. Okay. And it's 600 newtons per meter. Now I'm drawing a light because we're going to do the same thing here. We're going to calculate the distributed load and locate it at a single point because it works easier during the calculations that way. And essentially it's the same thing. We're just moving it. Okay. So let's see here. Let's draw the distances. So this is going to be halfway. Be 1 meter, and really this load goes out here like that. Okay, that's 1 meter. Remember when you're drawing your free body diagram to always draw the distances, label the points, label the axes, and label your forces. Okay, so we know, so this is our new distributed load here. It is half of this distributed load, so we're looking at this section here. Okay, so the area of this section is 1 times 600. It's going to be 600 newtons. I'll write that here, 600 newtons. Okay, and it's acting halfway between the 1 meter mark from here to here.